Hi, my name is Chadesha and my metric code is AE2062. So I'm from group 43 for the project assignment transform circuit. They are my group members Jachi, Yuzime, and Chai Chungkang. So I will be explaining for the menu solutions, and this is a diagram that I use for the menu solutions. And for the low is 0 and for height is 7.5, and this is a parallel RLC circuit I use for the menu solution in the project assignment. So first we find the omega equal to pi, then Vt equal to 7.5 from 0 to 1 and 0 from 1 to 2. So we find the A0 first equal to 1 over t, integrate from 0 to t ft dt, and the final answer equal to 3.75. Then we find the an equal to 2 over t, integrate from 0 to t ft cos n omega naught t dt. So it becomes 2 over 2 integrate from 0 to 1, 7.5 cos n pi t dt, equal to the final answer becomes 7.5 over n pi bracket sin n pi minus 0. And since sin n pi equal to 0 for the formula given, and the final answer for an will become 0. So then we enter the Bn. Bn also send equal to 2 over t integrate from 0 to t ft sin n omega naught t dt. So in this condition, after integrate will become minus 7.5 cos n pi t over n pi bracket from 0 to 1, and will become minus 7.5 over n pi bracket cos n pi minus 1. So the final answer will become 7.5 over n pi bracket 1 minus cos n pi, and since cos n pi equal to bracket 1 minus 1 power of n. So when n is odd, the value will become 15 over n pi, and when n is equal to even, the value will become 0. So the voltage source, the equation will become A0 plus summation n equal to 1 infinity an cos n pi t plus bn sin n pi t. So the A0 will be 3.75, and then since the an equal 0, and the bn will become 15 over n pi, then sin n pi t, where n equal to 2k minus 1. So it will only have the values when n is odd. So for the DC component, I0 equal to 3.75 over 20 plus 40 equal to 1 over 16, and for the K harmonic, Vs equal to 15 over n pi, and the phase angle equal 0. So for the capacitor equal to minus J20 over n pi, and the inductor equal to J0.1 n pi. Then we find the total impedance. First we parallel the capacitor with the resistor series with the inductor. Then we find together with the resistor, we add in. And then the final impedance will become 802 n pi plus j bracket minus 1200 plus 2 n square pi square bracket over 40 n pi plus j bracket minus 20 plus 0.1 n square pi square bracket. So this is the total impedance answer shown. Then to find the total current, will be by using Ohm's law. I equal to voltage source of the total impedance. So 50 over n pi divided by the answer given just now. Then we find the total answer will become the final answer will become 600 n pi plus j bracket minus 300 plus 1.5 n square pi square bracket over n pi bracket 802 n pi plus j minus 1200 plus 2 n square pi square. So for the I0, we find the I0 by using the current divider rule, which I0 equal to I1 over I1 plus I0 times I total. So this is a formula and the equation, and the final answer will become the minus j 300 over n pi bracket 802 n pi plus j bracket minus 1200 plus 2 n square pi square. So the I0 will become the 1 over 16 plus 300 over pi summation k equal to 1 infinity in sine 2 pi t minus delta n. And to find the 90 degree plus arctangent, this is the arctangent Bn over An. The Bn equal to 2 n square pi square minus 1200, and the An is 802 n pi. So for the value of In is 1 over sub An square plus Bn square. So this is the value. After we find the value of I0, we can find the I1 by using the Kirchhoff law. So I1 equal to I minus I0, which equal to the 600 n pi plus j 1.5 n square pi square minus j 100 over bracket n pi 802 n pi plus j bracket minus 1200 plus 2 n square pi square. So this one is the V1 equal to I1 Z1, V0 equal to I1, and then we find the total power. Total power equal to voltage source times the total current. Then the final answer we just times together. So the answer will become 9000 n pi plus j bracket minus 4500 plus 22.5 n square pi square bracket over n pi bracket 802 n pi plus j minus 1200 plus 2n square pi square. And then we find the nodal analysis for the V0. So we look at for the graph, this one Vs, we can assume V0 is here. So we can find the V0 we assume here. We can find the V0 through the nodal analysis. So we get back to here. We can find the Vs minus V0 over 20 equal to V0 over the capacitor impedance plus the V0 over the resistor plus the inductor. So we move on. Then the final answer we become like this. Then the final answer will become V0 equal to Vs 800 plus j 2n pi over bracket 801 minus 2n square pi square plus j 802 n pi. Then Vs equal to 15 over n pi. Then the final answer for the V0 will be 12,000 plus j 30 n pi over bracket n pi bracket 801 minus 2n square pi square plus j 802 n pi. So here I end my video for the manual simulation. I will pass to my group mate Yojime for the simulations. Thank you.
My name is Yojime and I'm going to present about the RLC circuit simulated by Matlab. So this is the circuit simulated by Matlab. Which the V source connected to R1 and R2 and an inductor and a capacitor is connected in parallel to the circuit. So for the V source, we can observe that the waveform is continuous square waveform and the frequency of FFT setting is set to 0.5 from 0.5 to 5 Hz. And the harmonic order of the voltage frequency diagram is generated, and we can observe that the value increased from 0 Hz to 1 Hz. And for the subsequence, the value only shows when the frequency is an odd number, which is 1, 3, 5, 7, and 9, and the value decreases. This goes same for current I1, which the value of frequency is set from 0.5 to 5. And we can observe that the value decreases with the increases of frequencies. Then this is for the current I1. Diagram shows that when the frequency is at even number, the current is minimum and the value of current is maximum at odd number. And for both even number and odd number, the value decreases with increasing even number and odd number. And this is for the total current. The current of even number is lower than that of odd number, and the current also decreases when the odd number or even number increases. And this is current. So this is a circuit for the total power, which the value is 2.47 watts. And for its diagram, the power decreases with the increasing odd number or even number, and the power value of even number is always lower than that of odd number.